Howdy! I'm here to talk about the force between a proton and electron and how to calculate that. So what they give us in the problem is that the force is equal to 3.5 times 10 to the negative 10 newtons, and they want to find the distance between a proton and an electron. The formula that I will be using is Coulomb's law, which is force equals a constant K times the charge on the first particle times charge on the second particle over distance squared. Now, since we want distance, we'll multiply both sides times distance squared, and we'll get to that point. And then by dividing by f and taking the square root of both sides, you'll get that distance is equal to the square root of that constant times the charge of the first particle times the charge of the second particle over the force. So according to the elementary charge of an electron, or a coulomb, QA and QB will be 1 times 10 to the negative 6, or 1 times 10 to the negative 19th coulombs, which is just the elementary charge of a proton or electron. So plugging all these values in, we get distance equals, and K is equal to 9 times 10 to the 9th Newton meters squared over Coulomb squared. So plugging all these in, we get 9 times 10 to the negative 9th Newton meters squared over Coulomb squared times 1.6 times 10 to the negative 19th coulombs, which is the amount of charge on the first electron or proton, times 1.6 and 10 to the negative 19th coulombs, which is the charge on the second either proton or electron, since they both have the same amount of charge, just either positive or negative, and divide that by the force, which is 3.5 times 10 to the negative 10th newtons. So canceling out units, coulombs will cancel out and newtons will cancel out, and by taking the square root you'll end up with meters, and the final answer should be 8.1 times 10 to the negative 10th meters.